look again at quadratic functions, and I'm going to start off by looking at particular quadratic function which has no coefficient of x squared other than 1. And I know that you're probably used to using ax squared plus bx plus c, but I think I'm emphasizing here that this is just a little bit different from that version, so I've decided to use K and H as my letters, okay? So there's nothing special about it, just to make it a bit different. So the crucial thing about this is that there's really a 1 in front of the x squared. And I'm going to develop a technique which is called completing the square. So let's have a specific example then. X squared plus 4x plus 7. Now, at a certain point in time, probably 200 or 300 years ago, people started to play around with this type of concept, and we are going to attempt to get rid of the x squared and turn it into a sort of linear thing in part. And what I'm going to do, I'm going to look at x plus 2 squared. Now don't worry at the moment why I'm using x plus 2. You'll see this as we go through it. If we do x plus 2 squared, we know that's x plus 2 times x plus 2. And again, the usual sort of thing. And let's hope that you could all get to x squared plus 4x plus 4. Now, look across here. X squared plus 4x plus nearly the same, but not the same. We need another 3 here. So what have I achieved so far? Well, I've achieved that x plus 2 squared is x squared plus 4x plus 4. Now, again, let's get the notation right because it's good to be correct. I should really put a 3-line equal sign there. That's an equivalent sign. And the equivalent sign means that this side is exactly the same as the other side, but written out in a different way. If I now add to each side 3, then I will get on the left x plus 2 squared plus 3, and on the right I get the 7, which of course is what I actually want. So I've started with this, which of course is an example of this type of thing here, and I've written it in a different way. And you'll notice that x no longer appears to be squared. Of course, it's a bit of a smoke and mirrors trick because it is going to be squared eventually because of that. But initially, it doesn't look as if it's been squared. Why did I choose 2? Well, I need to get 4x. And of course, the only way I get the x is when I'm doing this multiplied by that 2, and this multiplied by that 2. In other words, I do the same thing twice. So to get 4x, I halve the 4, which is why I've written 2 there. So once you learn what's going on here, it's a pretty simple trick to actually be able to do this process called completing the square. So let's work the process through then with another example. Let's have x squared plus, let's put an odd number in here. Why not? Plus 11. Okay, so what do we do first? We halve that number. X plus 2.5 squared. Now, the 11 is still there at the moment, but it's not going to end up as 11. So I need to know what happens. Well, if I square this bracket out, I get 2.5 squared. Now, I know what you're all thinking. Oh dear, I haven't got a calculator. 2.5 squared, extra bit of burden, but it's not a problem, is it? Because 2.5 is 5 over 2. So 5 over 2 squared is 25 over 4, which is 6.25. This means then that when I do this bracket squaring, I'm going to get plus 6.25, which I don't want. So I take it away again. So let's just run through that again. We halve this number, 2.5, and we put it inside the bracket. We then, because we're squaring this bracket, we square 2.5. We use our knowledge of fractions to make it easier. So 5 over 2 squared is 25 over 4, which is 6.25. We don't want that there. Take it away. Take it away there. So the final answer, and 11 take away 6.25 is plus 4.75. Okay, so I've managed then to take my quadratic function and I have completed the square. So as we progress through this topic, in the next lesson we'll look at some of the uses of this method, and when we've sorted that out in a further lesson, we'll then change. Remember, this is all about the coefficient of x squared being 1. So we'll then change it from being 1 into something else, and we'll look at the full completing the square method.